Hello, in this lecture we will find the area of triangle ABC in two different ways. In the drawing we have triangle ABC. We know that side AB of triangle ABC equals to 8 units, side AC of triangle ABC equals to 14 units, and we also know that this angle ABC equals to 2x, and this angle ACB equals to x degrees in size. And we want to find out the area of this triangle ABC. So first of all, I present you first method to find out the area of this triangle ABC. So in the first step, we'll draw a line segment from point A until it touches side BC in such a way that the line segment will create angle of 2x with side BC. So actually we will draw from point A line segment AD, so this, and the line segment touches side BC at point D. So AD creates angle 2x with side BC, that is to say angle ADB equals to 2x. Okay, so actually triangle ABD, this triangle has two equal angles. In triangle ABD we have two equal angles, and we have a rule. I will call it rule number 1. Rule number 1 states that in front of equal angles there are equal sides. Or you can also say that the sides that are in front of equal angles are equal to each other. Okay, so you can write down in that the sides, so rule number 1 states that the sides that are in front of equal angles are equal to each other. Again, rule number 1 states that the sides that are in front of equal angles are equal to each other. So actually, if you have a triangle ABC, that can be any triangle. It is not necessarily our triangle. So in this triangle ABC, we have two equal angles. Those angles are equal to each other. Both of them equal to alpha. According to rule number 1, the sides that are in front of the sides that are in front of equal angles are equal to each other. So the side that in front of this angle alpha is AB, and the side that is in front of this angle alpha is AC. So according to rule number 1, AB equals to AC. Okay, AB equals to AC. So if you have in a triangle two angles that are equal to each other, then the sides that are in front of those two equal angles are also will be equal to each other. So here we have in triangle ABC two angles that are equal to each other. Those two angles are equal to alpha. Therefore, in front of those two angles, you have two equal sides. That is to say, AB equals to AC. Okay, so actually we can implement rule number 1 in our triangle. We have triangle ABD. In triangle ABD, we have two angles that are equal to each other. Angle ADB equal to angle ABD, and both those two angles are equal to 2x. Again, in triangle ABD, we have two angles that are equal to each other. Both those two angles are equal to 2x. So according to rule number 1, the sides that are in front of those two angles are also equal to each other. The side that in front of this angle is AB, and the side that is in front of this angle is AD. So according to rule number 1, AB equals to AD. Okay, according to rule number 1, AB equals to AD. AB equals to AD, but we know that AB equals to 8 units. It is given us in the question. We know that AB equals to 8 units. So from this equality, we can deduce that AD also equals to 8 units. AD also equals to 8 units. Okay, so here AD equals to 8 units. Okay, and we have another rule, rule number 2, and according to rule number 2, so before I present you rule number 2, I will explain you what is exterior angle and what is interior angle. So actually, if we have triangle ABC, actually angle alpha, beta and gamma are defined as interior angles because they are inside triangle ABC. Again, those two angles are defined as interior angles, and also this angle is an interior angle, and those two angles are opposite to this angle, angle gamma. So those two angles are also defined as opposite interior angles because they are opposite in relation to angle gamma. Okay, so those angle alpha and beta are opposite interior angles, and angle ABL is defined, this angle is defined as exterior angle. Okay, so angle ABL, this angle is defined as exterior angle. So again, those two angles are defined, angle alpha and beta are defined as opposite interior angles, and angle ABL, this angle, is defined as exterior angle. Okay, so rule number 2 states that the exterior angle of a triangle that is to say, in this example is angle ABL is the exterior angle. The exterior angle in a triangle is equal to the sum of the opposite interior angles. So I will read rule number 2 again. Rule number 2 states that the exterior angles of a triangle is equal to the sum of the opposite interior angles. So in our example, the exterior angle ABL is equal to the sum of the opposite interior angles. So angle ABL equals to angle alpha plus beta. So according to rule number 2, the exterior angle ABL is equal to the sum of the angles of the opposite interior angles. Again, the exterior angle ABL equals to the sum of the opposite interior angles, that is to say angle ABL equals to angle alpha plus angle beta. Okay, those two angles are opposite interior angles, so angle ABL equals to angle alpha plus angle beta. Okay. So we actually can implement rule number 2 in our drawing, because actually we have triangle ADC. In triangle ADC, we have two opposite interior angles that are angle DAC and angle ACD, are opposite interior angles. They are opposite to angle ADC. They are opposite to angle ADC, this angle, and angle ADB, that equals to 2x, is the exterior angle of triangle ADC. Okay, so again, angles DAC and angle ACD are opposite interior angles, and angle ADB that equals to 2x. This angle is exterior angle of triangle ADC. So, okay, so angle DAC and angle ACD are opposite interior angles, and angle ADB that equals to 2x is the exterior angle of triangle ADC. So according to rule number 2, angle ADB that equals to 2x will be equal to the sum of the angles, angle ADC plus angle ACD. Again, according to rule number 2, the exterior angle of triangle ADC that is 2x will be equal to the sum of the angles, angle ADC plus angle DAC, according to rule number 2. The sum of those two opposite interior angles is equal to the exterior angle of triangle ADC. That is to say, the exterior angle is angle 2x, and it is equal to the sum of the two opposite interior angles, that is to say, to the sum of angle ADC plus angle ACD, according to rule number 2. But what is the value of angle ACD? Angle ACD equals to x. So we can substitute angle ACD by x, and we will get that 2x equals to angle ADC plus x. So in this equality, we substituted angle ACD by x because angle ACD equals to x, and we got this equality that states that 2x equals to angle ADC plus x. So here we can substitute x from this equality, and we will get that angle ADC equals to 2x minus x, that is x. So we found out that angle ADC equals to x degrees in size. Okay, so this angle again, according to rule number 2, angle DAC plus x plus angle ACD equals to 2x. Again, according to rule number 2, angle DAC plus angle ACD equals to 2x. Angle DAC plus angle ACD equals to 2x, to the exterior angle that is 2x. So we know that angle ACD equals to x, so we can substitute angle ACD by x. From this equality, this angle is angle DAC, So from this equality we'll substitute x, and we will get that angle DAC equals to 2x minus x, that equals to x. So angle DAC equals to x, this angle DAC equals to x. Okay? We found out that angle DAC equals to x, this angle equals to x, so in triangle DAC we have two equal angles. We have two equal angles. Again, in triangle ADC we have two, in triangle DAC we have two equal angles. Actually, in this triangle DAC, we have two equal angles, and according to rule number 1, in front of equal angles we have equal sides. So the side that is in front of this angle, angle X, is side DC, and the side that is in front of this angle is side AD. So according to rule number 1, AD equals to DC. Again, according to rule number 1, in front of equal angles we have equal sides, therefore AD equals to DC according to rule number 1. But we know that we have already found out that AD equals to 8 units. Okay, we can write here that AD equals to 8 units, and from this equality we can deduce that DC also equals to 8 units. DC equals to 8 units. Okay. From this equality we can deduce that DC equals to 8 units. Okay. DC equals to 8 units. So we can write here that DC equals to 8 units. Okay. And we also have rule number 3. Rule number 3 states that the height to the base in an isosceles triangle divide the base to two equal parts. So I will read rule number 3 again. Rule number 3 states that the height to the base in an isosceles triangle divides the base to two equal parts. Okay, so actually if we have a triangle ABC, that can be any isosceles triangle, so if this triangle ABC is an isosceles triangle, that is to say side AB equals to side AC, side AB equals to side AC, and the base of triangle ABC is side BC. Again, the side BC is the base of triangle ABC. We know that AB equals to AC, and the base of triangle ABC is BC. Then if we draw perpendicular to the base from point A, if we draw perpendicular from point A to the base BC, so this angle is a right angle and this angle is also a right angle. So this is the perpendicular from point A to the base of triangle ABC, that is BC, and we will call to the touching point between the perpendicular to side BC of triangle ABC point D. Then, according to rule number 3, the height AD divides the base BC to two equal parts, that is to say BD equals to DC. Okay, so according to rule number 3, whenever we draw a perpendicular to the base of an isosceles triangle, then that height divides the base to two equal sides, that is to say BD equals to DC. Okay, BD equals to DC according to rule number 3. Okay, again, BD equals to DC according to rule number 3. Okay, and again, we can implement rule number 3 in the isosceles triangle ABD. This triangle ABD is an isosceles triangle because of the fact that AB equals to AD. Both of those two sides are equal to 8 units. AB equals to 8 units and AD also equals to 8 units. Therefore, triangle ABD is an isosceles triangle. So according to rule number 3, if from point A we will draw perpendicular to the base BD, then that height so this is height to the base BD, therefore this angle is a right angle, and also this angle equals to 90 degrees. We will call to the touching point between the perpendicular to the base BD point E. So according to rule number 3, the height AE divides the base BD to two equal sides. According to rule number 3, BE equals to ED. Okay, according to rule number 3, BE equals to ED. Okay, in triangle ABD, in the isosceles triangle ABD, the height AE divides the base to two equal sides. That is to say, BE equals to ED according to rule number 3. Again, in the isosceles triangle ABD, according to rule number 3, the height AE divides the base BD to two equal sides. That is to say, BE equals to ED. Okay, BE equals to ED, and if we define BE as A, that is to say, BE equals to A, so if BE equals to A, we can deduce from this equality that ED also will be equal to A. ED also will be equal to A. Okay. ED will be also equal to A according, okay, we can deduce it from this equality, okay, that ED also equals to A. So actually we have here two right triangles. Triangle ABE is a right triangle because of the fact that this angle is right angle. So triangle ABE has one angle that is a right angle, therefore triangle ABE is a right triangle. So in the right triangle we can implement the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to BE square plus AE square. And we will also define AE as H. Okay, AE equals to age according to our definition. So in the right triangle, according to the Pythagorean theorem, so according to the Pythagorean theorem, in the right triangle, triangle ABE, AB squared, that is the square of the hypotenuse, equals to the sum of the squares of the perpendiculars, equals to BE squared plus AE squared. Okay, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, but what is the value of AB? AB equals to 8 units. It is given us in the question. So AB squared will be equal to 64 because it is 8 squared. 64 equals to BE. BE equals to A according to our definition. So BE squared equals to A squared. And what is the value of AE? AE equals to age according to our definition. So AE squared equals to A squared. So we got in the question number 1 states that 64 equals to A squared plus 8 squared. Here we will subtract A squared from equation number 1 and we will get that H squared equals to 64 minus A squared. So question number 1 states that H squared equals to 64 minus A squared. So actually triangle AEC is a right triangle because it has one angle that equals to 90 degrees. This angle, angle AEC, is a right angle. Therefore, triangle AEC is a right triangle. Triangle AEC is a right triangle. Because of the fact that angle AEC is a right angle. Again, triangle AEC is a right triangle because it has one angle that is 90 degrees. This angle AEC equals to 90 degrees, therefore triangle AEC is a right triangle. And again, we can implement the law of Pythagoras in the right triangle AEC. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is AC, so the square of the hypotenuse is AC square. Again, we relate to the right triangle, triangle AC. The square of the hypotenuse is AC square equals to the sum of the squares of the perpendiculars equals to AE square plus EC square. So we implement the Pythagorean theorem in the right triangle, triangle AEC. The square of the hypotenuse, that is AC square, equals to the sum of the squares of the perpendiculars, equals to AE square plus AC square. But what is the value of AC? The value of AC equals to 14 units. It is given us in the question. So AC square is 14 square, and 14 square is 196, equals to AE square. AE equals to H, so AE square is H square. And what is the value of EC? EC equals to A plus 8. Again, EC equals to A plus 8. So EC square will be equal to A plus 8 square. In total, we got that 196, that is AC square, equals to AE square, that is H square, plus EC square equals to A plus 8 square. But we have already found out that H square, from equation number 1, we know that H square equals to 64 minus A square. So we can substitute H square from equation number 2 by 64 by minus A square, because it equals to H square. So we will do it now. And we will get that 196 equals to 64, H square is 64 minus A square plus A plus H square. A plus H square equals to A square plus 64 plus 16A. Okay, so in total we got that question number 2 states that 196 equals to 64 minus A square plus A square. Minus A square plus A square is 0, so we can cancel A square, plus 64 plus 16A. So 64 plus 64 is 128, so I will write it down. We got that 196 equals to 128 plus 16A. Okay, 196 equals to 128 plus 16A. Here we will subtract 128 from this equality. This is the question number 2. And we will get that question number 2 states that 196 minus 128 equals to 68. It equals to 16A. So according to question number 2, 16A equals to 68. Here we divide equation number 2 by 16 in order to get the value of A. So A will be equal to 68 over 16. We can divide the numerator and the denominator by 4, and we will get 68 by 4 is 17, and 16 over 4 equals to 4. So we got that A equals to 17 over 4 units. Okay, we found out the value of A. A equals to 17 over 4 units. But we have equation number 1 that states that h squared equals to 64 minus a squared. So we can substitute a squared by 17 over 4 squared. And we will get that h squared equals to 64 minus 17 squared is 289 over 4 squared is 16. So we got that h squared equals to 64 minus 289 minus over 16. So here we will multiply 64 by 16 and then we will divide it by 16 in order to get common factor in the denominator, that is 16. In order that 64 will have the common factor of 16 in the denominator. So we will multiply it by 16 and then we will divide it by 16. Okay, so we will get that h squared equals to 64 times 16 is 1024 over 16 minus 289. Okay, so we got that h squared equals to 1024 minus 289 over 16. 1024 minus 289 equals to 735. So I write it down. So h squared equals to 735 over 16. So here we will take a root out of this equality and we will get that h equals to the root of 735 over 16. 735 equals to 3 times 5 times 7 times 7 and 16 equals to 4 times 4. Okay, so h equals to 3 times 5 times 7 times 7 over 4 times 4. The root of 7 times 7 is 7 and the root of 4 times 4 is 4. So I write it down. We got that h equals to 7 is out of the root. We also have 4 out of the root. Inside the root, what is left is 3 times 5, that is root 15. So in total we got the value of h, it equals to 7 over 4 times root 15 units. And we have already found out that a equals to 17 over 4 units. Okay, so we have the values of age and A. Okay, so what is the area of triangle ABC? The area of any triangle, area A is abbreviation for area. So the area of any triangle equals to the base of the triangle times the height to the base. You should remember that the height must create 90 degrees with the base over 2. Okay, so the area of any triangle equals to the base of the triangle times the height to the base over 2. And the area of triangle ABC will be equal to the base of the triangle. What is the base of triangle ABC? The base is BC. Okay, the base is BC. And what is the height? The height must create 90 degrees with the base. And the edge, or AE, that is edge, is the base of is the height of triangle ABC, because this height, edge, creates 90 degrees with the base BC. Therefore, edge is the height of triangle ABC. So the height is h over 2. So the area of triangle ABC equals to the base BC times the height to the base, that is h over 2. We know that h equals to 7 over 4 times root 15 units. And what is the value of BC? The value of BC is actually, this is BC, so the value of BC is A plus 8, or the value of BC is 2A plus 8. So BC equals to 2A plus 8. And we have already found out that h equals to 7 over 4 times root 15 units over 2. So the area of triangle ABC equals to 2 times A plus 8 times 7 over 4 times root 15 over 2. And we know that A equals to 17 over 4 units. So we can substitute A by 17 over 4 units. And we will get that the area of triangle ABC equals to 2 times A. A equals to 17 over 4. So 2 times 17 over 4 is 17 over 2. 17 over 2 plus 8 times 7 over 4 times root 15. Here we can move the 2 to the denominator here, and we will get that 2 times 4 is 8. So in total we will get that it equals to 7 times root 15 over 8. Okay, so the area of triangle ABC equals to 17 over 2 plus 8 times 7 times root 15 over 8. Here, instead of 8, we will write 16 over 2 in order to have a common factor with this number. So we get that the area of triangle ABC equals to 17 over 2 plus 16 over 2. 8 is 16 over 2, so we change nothing. Plus 16 times 7 times root 15 over 8. So here 17 plus 16 is 33 and 2 times 8 is 16. So I write it down. The area of triangle ABC will be equal to 33 times 7 times root 15. 2 times 8 is 16. So the area of triangle ABC (17 plus 16 is 33). So the area of triangle ABC equals to 33 times 7 times root 15 over 16. 33 times 7 is 231. So I will write it down. So the final answer for the area of triangle ABC is actually root 15 times 231 over 16 square units. Again, the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, so in the next step I will present to you second method to find out the area of triangle ABC. Okay. So we want to find out the area of this triangle ABC. First of all, we will find out the area of this angle BAC. We know that the sum of the angles in any triangle equals to 180 degrees. So the sum of angles A plus B plus C must be equal to 180 degrees. So we can write down that the sum of angle A plus angle B, that is 2x, plus angle C, that is x, must be equal to 180 degrees. Okay, so we got this equality that states that angle A plus 2x plus x equals to 180 degrees. So 2x plus x is 3x. So we'll get that angle A plus 3x equals to 180 degrees. So here we will subtract 3x from this equality in order to get the value of angle A. So the value of angle A equals to 180 degrees minus 3x. Okay, we found out the value of angle A. Angle A equals to 180 degrees minus 3x. So we can write here that angle A equals to 180 degrees minus 3x. Okay, so in the next step I will present to you a new rule that will be rule number 4, that is a new formula for the area of any triangle. According to rule number 4, the area of any triangle can be calculated according to the following formula. First of all, I will draw a triangle ABC, that can be any triangle, not necessarily our triangle, but any other triangle. If we have triangle ABC, and we know that the size of side AB is A units, the size of side AC equals to B units, and we also know that the angle between side AB and side AC of triangle ABC is theta. Then, according to rule number 4, the area of this triangle ABC, that can be any triangle, A is abbreviation for area, the area of this triangle will be equal to A times B times sinus theta over 2. Okay? So the area of this triangle ABC, is equal to the multiplication of the two sides by each other, and then we will multiply the outcome by the sine of this angle, that is actually sine theta, and then we will divide all by 2. That is the area of any triangle. So in order to know the area of any triangle, we must to know the size of side AB and also the size of side AC, and also the value of angle theta, and then we will find the area of the triangle. And again, we can implement rule number 4 in our triangle, and we will find the area of our triangle ABC, according to rule number 4. Because the area of our triangle ABC, the area A is abbreviation for area, so the area of triangle ABC will be equal to AB times AC times sinus 180 degrees minus 3x, sine of 180 degrees minus 3x, all divided by 2. Again, the area of our triangle ABC, will be equal, according to rule number 4, to AB times AC times sine of 180 degrees minus 3x over 2. Okay, but what is the value of AB? AB equals to 8 units. AC equals to 14 units. It is given us in the question, times sine of 180 degrees minus 3x over 2. So the area of triangle ABC will be equal to 8 times 14 times sine of 180 degrees minus 3x over 2. Here 14 over 2 is 7, and 7 times 8 is 56, so I will write it down. The area of triangle ABC will be equal to 56 times sine of 180 degrees minus 3x. Okay, the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. Here we have a trigonometric identity that states that sine 180 degrees minus alpha equals to sine alpha. So according to this trigonometric identity, we can write down that sine of 180 degrees minus 3x equals to sine 3x. Okay? So the area of triangle ABC, that will be equation number 1, equals to 56 sine 3x. Okay, that is equation number 1. In the next step, I will present to you a new rule, rule number 5, and we will implement rule number 5 in our triangle ABC. Rule number 5 is actually the law of sines. Okay. Rule number 5 is the law of sines. The law of sines is valid for any triangle. So first of all, I will write that in any triangle, if we have triangle ABC, that can be any triangle, not necessarily our triangle, but any other triangle. and we know that side AB of triangle ABC equals to C units, side AC equals to B units, and side BC equals to A units, and capital A is the size of this angle, capital B is the size of this angle, and capital C is the size of this angle. Then, according to the law of sines, A over sinus A over sinus A will be equal to B over sinus B. Again, B is the size of this angle, and A also is the size of this angle, and C is the size of this angle. So A over sinus A will be equal to B over sinus B, and will be equal also to C over sinus C. Again, we can implement this formula in any triangle. The law of sines states that A over sinus A equals to B over sinus B equals to C over sinus C. Okay, so we actually can implement the law of sines in our triangle ABC, according to the law of sines. AC over sinus 2x equals to AB over sinus x. Again, according to the law of sines, AC over sinus 2x equals to AB over sinus x. But what is the value of AC? The value of AC equals to 14 units. So 14 over sinus 2x equals to AB. What is the value of AB? AB equals to 8 units. It is given us in the question. To 8 over sine x. So in total we got that 14 over sine 2x equals to 8 over sine x. So what is the value of sine 2x? We have trigonometric identity. So the value of sine 2x equals to 2 sine x times cosine x. Again, sine 2x equals to 2 sine x times cosine x. So we can write down that 14 over sine 2x that equals to 2 sine x cosine x, 2 sine x times cosine x equals to 8 over sine x. Okay, so here we can cancel sine x because we have sine x in the denominator of this side of the equation, and we have sine x in the denominator of the other side of this side of the equation, so we can cancel sine x. And 14 over 2 is 7. So we'll get that 7 over cosine x equals to 8. So we got that 7 over cosine x equals to 8. Here we will multiply this equality by cosine x and then we will divide it by 8. We will get that cosine x equals to 7 over 8. So in the next step I will present to you a new trigonometric identity, and with that trigonometric identity we will find out the value of sine x. So the trigonometric identity states that sine square x plus cosine square x equals to 1. Okay? From this trigonometric identity that states that sine square x plus cosine square x equals to 1, we'll find out the value of sine x. So first of all, we will subtract cosine square x from this trigonometric identity, and we will get that sine square x equals to 1 minus cosine square x. So here we will take a root out of this equality in order to find out the value of sine x. Sine x will be equal to the root of 1 minus cosine square x. Okay? So we will square this equality in order to find out the value of cosine square x. So cosine square x will be equal to 7 squared, that is 49, over 8 squared, that is 64. So in the next step we will substitute cosine square x by 49 over 64, because cosine square x equals to 49 over 64. So we will get that sine x equals to the root of 1 minus cosine square x equals to 49 over 64. So what is the value of, first of all, we will substitute 1 by 64 over 64. In this way we will have a common factor of 64 in the denominator. So sine x equals to the root of 64 over 64, 64 minus 49 over 64. So we got that the value of sine x is actually 64 minus 49 over 64. 64 minus 49 equals to 15. So I write it down. The value of sine x actually equals to root 15, and the root of 64 is 8. So we found out that sine x equals to root 15 over 8. Equation number 1 states that the area of triangle ABC equals to 56 times sine 3x. In the next step, I will present you a new trigonometric identity for sine 3x. According to the following trigonometric identity, sine 3x equals to 3 sine x minus 4 sine cube x. Okay? Again, sine 3x equals to 3 sine x minus 4 sine cube x. So we can substitute sine x by this expression, because this expression equals to sine 3x. Okay, and we will get that the area of triangle ABC equals to 56 times 3 sine x minus 4 sine cube x. So here we will take out sine x as a common factor of this expression, and we will get that the area of triangle ABC equals to 56. We take sine x as a common factor of this expression. Sine x, in the brackets, what is left is 3 minus 4 sine square x. So in total we got that the area of triangle ABC equals to 56 in the 56 sine x. In the brackets we have 3 minus 4 sine square x. We know that sine x equals to root 15 over 8. We will square this equality in order to find out the value of sine square x. So after we squared this equality, we will get that sine square x equals to root 15 times root 15 is 15, and 8 square is 64. So in total we got that sine x equals to root 15 over 8, and sine square x equals to 15 over 64. And so the only thing that is left is to substitute sine x by root 15 over 8, and to substitute sine square x by 15 over 64. Okay, so we will do it now, and the area of triangle ABC will be equal to 56. Again, sine x equals to root 15 over 8. Times 3 minus 4 sine square x equals to 15 over 64. So in total we got that the area of triangle ABC equals to 56 times root 15 over 8. In the brackets we have 3 minus 15, 4 times 15 over 64. So here we can divide we can cancel 4, so actually we will divide the numerator and the denominator by 4. So here we will cancel 4, and in the denominator 64 over 4 is 16. Okay, and here 64 over 8 is 7. So I write it down. We'll get that the area of triangle ABC equals to 54 over 8 is 7. So it is root 15 times 7. Here we have 3 minus 4 is cancelled, and 64 over 4 is 16. So it is actually 15 over 16. So here we will write 68 over 16 in order to have a common factor in the denominator, that is 16. Okay, so we will get that the area of triangle ABC equals to root 15, and we write 48 over 16 minus 15. Okay, so the area of triangle ABC equals to root 15 times 7. The area of triangle ABC equals to root 15 times 7. 48 minus 15 is 33, so I write it down. So the area of triangle ABC equals to root 15 times 7. 48 minus 15 is 33 over 16. Okay, the area of triangle ABC equals to root 15. 7 times 33 is 231. So the final answer is that the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, so the area of triangle ABC equals to root 15 times 231 over 16 square units. Now we will check if we got the same answer in the first method. In the first method, we found out that the area of triangle ABC equals to root 15 times 231 over 16 square units. So we have the same results for the area of triangle ABC. It is the same in both methods. That is the implication that we didn't make any mistakes. We didn't make any mistakes. Okay, so I will summarize the lecture. Actually, we wanted to find out the area of triangle ABC. Okay, we wanted to find out the area of this triangle ABC. First of all, we drew line segment AD in such a way that angle ADB equals to 2x. So triangle ABD has two equal angles. Those two angles are equal to each other. Both of them are equal to 2x. And we have rule number 1 that states that the sides that are in front of equal angles are equal to each other. So actually, if we have triangle ABC that has two angles that are equal to each other, both of those two angles are equal to alpha. According to rule number 1, the sides that are in front of equal angles are equal to each other. So in front of this angle alpha we have side AC, and in front of this angle alpha we have side AB. So according to rule number 1, the sides that are in front of equal angles are also equal to each other. That is to say, AB equals to AC. Okay, so we actually can implement rule number 1 in our drawing, because we have the triangle ABD that has two equal angles, and according to rule number 1, the sides that are in front of those two equal angles are also equal to each other. In front of this angle 2x we have AD, and in front of this angle 2x we have AB. So according to rule number 1, AB will be equal to AD. Okay, according to rule number 1, AB equals to AD because of the fact that in front of equal angles we have equal sides. Therefore, AB equals to AD, because AB is in front of this angle 2x, and AD is in front of this angle 2x. And they are equal to each other. That is to say, AB equal to AD. AB equals to AD, and we know that AB equals to 8 units. AB equals to 8 units. So we can deduce from this equality that AD also equals to 8 units. Okay, so AD equals to 8 units. So AD is 8 units. And we have rule number 2 that states that the exterior angle of a triangle is equal to the sum of the opposite interior angles. So here triangle, in triangle ABC we have three interior angles that are A, B, alpha, beta and gamma, and angle ABL is exterior angle of triangle ABC. So according to rule number 1, according to rule number 2, the exterior angles, the exterior angle of a triangle is equal to the sum of the opposite interior angles. So this exterior angle, angle ABL, is equal to the sum of the two opposite interior angles. That is to say, angle ABL, the exterior angle ABL equals to angle alpha plus angle beta. Okay, the exterior angle ABL equals to the opposite interior angles, that is to say angle ABL equals to alpha plus beta. Okay, so we can implement rule number 2 in our drawing, because we have triangle ADC that has two interior angles, and this angle ADB is exterior angle in relation to triangle ADC. So according to rule number 2, the exterior angle ADB that equals to 2x equals to the sum of the opposite interior angles equals to angle DAC plus angle ACD. Again, the exterior angle 2x equals to angle DAC plus angle DCA according to rule number 2. This angle, the exterior angle 2x, equals to the two opposite interior angles that are angle DAC plus angle ACD. Okay, again, 2x equals to angle DAC plus angle ACD, but we know that angle ACD equals to x. It is given us in the question, so we can substitute x from this equality, and we will get that angle DAC equals to x degrees. This angle equals to x degrees. So in triangle ADC we have two equal angles, and according to rule number 1, in front of equal angles we have equal sides. So this angle x is in front of AD, and this angle x is in front of DC. So according to rule number 1, AD equals to DC. According to rule number 1, AD equals to DC. But we know that AD equals to 8 units. We have already found out that AD equals to 8 units. AD equals to 8 units. So from this equality we can deduce that DC also equals to 8 units. Okay, DC also equals to 8 units. So here DC equals to 8 units. Okay, and then we have rule number 3 that states that the height to the base in an isosceles triangle divide the base to two equal parts. So rule number 3 states that if you have an isosceles triangle, triangle ABC is an isosceles triangle, that is to say AB equals to AC, then if you draw a perpendicular to the base from point A, this is the base of triangle ABC. So if you draw a perpendicular from point A to the base BC, then that perpendicular AD divides the base BC to two equal parts. That is to say BD equals to DC. Okay, BD equals to BD equals to DC. Okay, BD equals to DC. BD equals to DC. Again, if you have isosceles triangle, that is to say AB equals to AC, and you draw a perpendicular from point A to the base BC, then this perpendicular divides the base BC to two equal parts, that is to say BD equals to DC. And again, we can implement rule number 3 in our isosceles triangle ABD. Triangle ABD is an isosceles triangle because AB equals to AD equals to 8 units. So if we draw a perpendicular to the base BD, then according to rule number 3, it divides the base to two equal parts. That is to say BE equals to ED. Again, the height to the base BD divides the base to two equal parts. That is to say BE equals to ED. So if we define BE as A, is BE equals to A, we can deduce from this equality that ED also will be equal to A. So ED also will be equal to A. Okay, so here we have right triangle. This triangle ABE, is a right triangle because it has angle of 90 degrees. So we can implement the Pythagoras theorem in this right triangle. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to AE square plus BE square. Okay, AB square equals to BE square plus AE square, and we know that AB equals to 8 units, so AB square is 8 square, 8 square is 64, BE equals to A, so BE square is A square, and AE equals to H, so AE square is S square. So in total we got that H square equals to 64 minus A square. And we also have second right triangle, triangle AEC is also a right triangle, so we can implement the Pythagoras theorem that states that the square of the hypotenuse, that is to say AC square, will be equal to the sum of the squares of the perpendiculars, will be equal to AE square plus EC square. Again, in the right triangle AEC, AC square equals to AE square plus EC square. And we know that AC equals to 14, so AC square is 14 square, 14 square is 196, AE equals to H, so AE square is H square, and EC equals to A plus 8, so EC square equals to A plus 8 square, and we have here 196 equals to S square plus A plus 8 square, but we have already found out that H square equals to 64 minus A square, so we can substitute H square by 64 minus A square. So here we left with only one variable, that is A, so we solved this equation and we found out that A equals to 17 over 4 units, and we have the equality that says that A square equals to 64 minus A square, So we can substitute a square by 17 over 4 square, that is 298 over 16, and we have only one variable missing, that is h. We solved this equality and we found that h equals to 7 over 4 times root 15 units, and we have already found out that a equals to 17 over 4 units. So now we can find the area of triangle ABC, because we know that the area of any triangle equals to the base of the triangle times the height to the base over 2. And the base of triangle ABC is BC, and the height to the base is AE, that is h. We know that value of h, and so the area of triangle ABC equals to the base BC times the height h over 2. Okay, so the area of triangle ABC equals to the base BC times the height to the base over 2. And what is the value of BC? BC equals to A plus A plus 8. A plus A plus 8, so BC equals to 2A plus 8. BC equals to 2A plus 8, and we have already found out that h equals to 7 over 4 times root 15 units. And we know that A equals to 17 over 4 units. Okay, so if A equals to 17 over 4 units, then 2 times A will be equal to 17 over 2 units. So we found out that the area of triangle ABC equals to root 15 times 231 over 16 square units. Again, the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, that was the first method to find out the area of triangle ABC. And we also found out the area of triangle ABC in a second method. So in a second method, first of all, we found the size of angle A by the equality that states that the sum of the angles in any triangle equals to 180 degrees. So angle A plus angle B plus angle C must be equal to 180 degrees. So angle A plus angle B, that is 2x, plus angle C, that is x, must be equal to 180 degrees. From this equality, we found that A equals to 180 degrees minus 3x. Angle A equals to 180 degrees minus 3x. And then I presented to you a new formula for the area of any triangle. That is actually also rule number 4. The formula for the area of any triangle is actually A times B times sinus theta over 2. The area of any triangle can be found according to the formula that states that A times B times sinus theta over 2 equals to the area of the triangle. Okay, so we implemented rule number 4 in our triangle. According to rule number 4, the area of our triangle ABC will be equal to AB times AC times sinus 180 degrees minus 3x over 2. Again, the area of our triangle ABC will be equal to AB times AC times sinus 180 degrees minus 3x over 2. We know that AB equals to 8, AC equals to 14 units, and we have sinus 180 degrees minus 3x over 2. So we got that the area of triangle ABC equals to 56 times sinus 180 degrees minus 3x, but we have the trigonometric identity that states that sinus 180 degrees minus alpha equals to sinus alpha. So according to this equality, the value of sinus 180 degrees minus 3x is sinus 3x. So in total we got that the area of triangle ABC equals to 56 times sinus times sine 3x. Okay, then I presented to you rule number 5, that is actually the law of sines. According to the law of sines, in any triangle, A over sinus A equals to B over sinus B equals to C over sinus C. Again, in any triangle, A over sinus A equals to B over sinus B equals to C over sinus C. When capital A, capital B, and capital C are also the sizes of the angles. Capital A is the size of this angle, capital B is the size of this angle, and capital C is the size of this angle. So according to this formula, A over sinus A equals to C over sinus B equals A over sinus A equals to B over sinus B equals to C over sinus C. So we can implement the law of cosines, the law of sines, in our triangle ABC, according to the law of sines. AC over sinus 2x will be equal to AB over sinus x. Okay, AC over sinus 2x will be equal to AB over sinus x. We know that AC equals to 14 units and AB equals to 8 units. And the sinus 2x equals to 2 sinus x times cosinus x. So we can write instead of sinus 2x, 2 sinus x cosinus x. So here sinus x is cancelled because we have sinus x in both sides of the equation, and we got that sinus 7 over cosinus x equals to 8. From this equality we got that cosinus x equals to 7 over 8, and we have the trigonometric identity that states that sine square x plus cosine square x equals to 1. From this trigonometric identity, we will get that sine x equals to the root of 1 minus cosine x, and we know that cosine x equals to 7 over 8, so if we square this equality, we will get that cosine square x will be equal to 49 over 64. So we can substitute cosine square x by 49 over 64 because 49 over 64 equals to cosine square x. And we will get that sine x equals to the root of 1 minus cosine x, cosine square x equals to 49 over 64. So we got that sine x equals to root 15 over 8. And we have equation number 1 that states that the area of triangle ABC equals to 56 times sine 3x. And we have the trigonometric identity that states that sine 3x equals to 3 sine x minus 4 sine cube x. So we substituted sine 3x by this expression, and we got that the area of triangle ABC equals to, actually we we have this equality that the area of triangle ABC equals to 56 times sine x times 3 minus 3 sine square x, and we know that sine x equals to root 15 over 8, and sine cube x equals to 15 over 64. So we can substitute sine x by root 15 over 8, and we can substitute sine cube x in this equation number 1 by 15 over 64. Okay? And after we did the substitutions, we got the area of triangle ABC. We found out that the area of triangle ABC equals to root 15 times 231 over 16 square units, and it is exactly the same result that we got in the first method. Okay, so the area of this triangle ABC, according to the second method, equals to root 15 times 231 over 16 square units. Okay, thank you very much.